Hey math fans, we're on section 6.1.2. Let's get started. In this section, we're going to be writing slopes for lines that are parallel or perpendicular to another line. Remember that parallel lines are always equal, and the slopes of perpendicular lines are something called opposite reciprocals. So if it's positive, it needs to be negative, and then you also have to do the reciprocal. We usually use slope-intercept form, but I want to tell you about another type of form, which is called point slope form, and it's circled here in yellow. It's y minus y1 equals m times x minus x1. Be careful of those minus signs because minus and negative will give you a positive. Either point slope or slope intercept form is fine to use when writing an equation, but most of the time the answers are supposed to be in slope intercept form. Once again, parallel lines will have the same slope and perpendicular lines will have opposite reciprocal slopes. I like the word opposite better than negative because that, if you do take the opposite of a negative number, it'll become positive, and the opposite of a positive number will become negative. So that's why I prefer the word opposite instead of negative reciprocal. One thing to consider is when you have a line and then a point that's not on the line, the shortest distance between a point and a line is going to be a perpendicular to that line. Here are some common errors and misconceptions. Example 1 says, write the slope-intercept form of an equation for a line that passes through the point 5, negative 2 and is parallel to the graph of 8x minus 2y equals 6. Now I'm noticing that that's not written in slope-intercept form, so that's going to be our first move, is to write that into slope-intercept form. So after doing some rearranging, we get y is equal to 4x minus 3. The whole point of doing that is because we need to take the slope from this line, and that way we can write the new equation using 5, negative 2. So the slope of 4x minus 3 is going to be 4. Now we're going to be using this point slope form. Now we're usually used to working with slope intercept, which is fine. I'll show you that way as well. But look how point slope works. What you do is you go y minus y1. Now notice down here that y1 is a negative. So that y minus negative 2 will become positive. And then it's x minus x1. And x is just 5, so it'll be x minus 5. So that gives you y plus 2 equals 4x minus 20, and you get a final answer of y equals 4x minus 22. So 4x minus 22 is going to be parallel to that 8x minus 2y equals 6. And that 4x minus 22 also goes through the point 5, negative 2. If you don't want to use point slope form, you can still use slope intercept form. You just write y equals mx plus b, substitute the 4 in for m, substitute negative 2 in for y, and then 5 in for x because it was 5, negative 2, x, y. And you get a b value of negative 22. And so with a b or intercept of negative 22 and a slope of 4, you can just write the equation 4x minus 22, and you get the same answer as using the point slope form. So that's two different ways you can write this equation. And here's a graph of both the lines, and notice that the 4x minus 22 is going through the point 5, negative 2. Again, parallel lines will have the same slope. Example 2, write the slope-intercept form of an equation for the line that passes through the point negative 1, 6 and is perpendicular to the graph negative 10x plus 5y equals 20. So again, rewrite the equation in slope-intercept form. As you can see, y equals 2x plus 4. The slope is 2. Now we're not going to be writing a parallel line. We're writing a perpendicular line, so we need to make the opposite reciprocal. The opposite reciprocal of 2 is going to be negative 1/2. Again, opposite reciprocal means that you do the opposite of whatever number you have, and then reciprocal, flip it. Remember, a whole number is 2 over 1, so it'll become 1 over 2. And then we can substitute it, in this case, into point-slope form. And then keep in mind, x minus -1 is really going to be x plus 1, distribute the 1/2, and then you get y equals -1/2 plus 11 over 2. That's going to be going through the point -1, 6, and it will also be perpendicular to the line that was given. And here it is. And as you can see, the line is going through -1, 6. Again, if lines are perpendicular, their slopes will be opposite reciprocals. Example 3, find the point on the line y equals 4x plus 1 that is closest to the point -2, 8. Now that term closest means that if I was to graph this, the point on the red line that would be the closest would be perpendicular to the red line. So what I'm going to need is that perpendicular slope. Okay, so what we're going to do first is we're going to write the equation of the line, y equals 4x plus 1. We're going to identify the slope as 4, so we're going to do the opposite reciprocal, which is -1 over 4. And we're going to use that -1 over 4 in the point slope or slope-intercept to get our equation. After doing a little bit of substituting, we finally get an answer of y equals -1 over 4x plus 15 over 2. And here's a graph of both of those lines. And if you really want to know what's that point, what's the point right there that's closest to the other point, basically it'll be the intersection of those lines, which means you'd have to solve this system. There's several different ways you can solve a system of linear equations. You can use substitution, but I'm just going to warn you, this particular problem comes out with a pretty crazy looking fraction like x equals 26 over 17 once you solve for x, and now you need to plug it back in. Or I would say you could just use Desmos. I would say graph both of these lines. You could use Desmos. It will identify the point of intersection for you, and there is a rounded approximation for that point of intersection that would be closest to -2, 8. And that's going to do it for this section. We'll see you in class.